actually swapped. So today we are doing 7.4 notes, and you have a worksheet for homework tonight, so you don't need your Chromebooks. So go ahead and open up to the rectangles page. This is section 7.4 in your books, and you do have homework for homework tonight, which is a worksheet on rectangles. All right. So, we are talking about quadrilaterals. This entire unit is quadrilaterals, yeah? Yeah. What are quadrilaterals? Four-sided figures. Not necessarily equal, just four sides, okay? So any four-sided figure is a quadrilateral. Within all of those quadrilaterals, we have what we have been talking about, which are parallelograms. And they are special quadrilaterals. And we know that, as the name suggests, opposite sides are parallel. They also happen to be congruent. Opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other. These are all properties of parallelograms. Today we're talking about rectangles, which are more special parallelograms. So rectangles are a part of the parallelogram universe, but they have a couple extra properties. So the first thing, what do you know about rectangles?
There's two different sides.
Two different side lengths. Okay. That's the same here. Two opposite sides are congruent. It's the same as parallelograms, in fact. What's more special about rectangles?
Okay, how consecutive angles are supplementary?
So still true. Perpendicular lines, yes. We have, in a rectangle, the sides are perpendicular. We have four right angles. All four angles are right angles. All right? To make it a rectangle, there are four 90-degree angles. And so that's extra special. It also gives us something else rather interesting. Because we have right angles, the diagonals turn out to be the same length. So these diagonals are congruent. Now, they are congruent, but from before, they still bisect each other. And so we have the whole diagonal start out at the same length, and then those little diagonals turn out to bisect each other. So in fact, we get four little baby diagonals that are all the same length, and that makes it kind of interesting. We get little triangles here that are isosceles. And so if we have two congruent sides in a triangle, we also have congruent base angles. And there's lots of these little isosceles triangles in a rectangle. So that's something we want to pay attention to. But we're talking all about rectangles today. So each quadrilateral below is a rectangle. We're going to use that information and look at number 2 here. We have a little rectangle here. This little piece is 15, so AE is 15. What else do you know if AE is 15? CE is also 15.
That means that DE is 15.
Yeah, all these little baby diagonals are all the same length because we have a rectangle here. All right, so that means, what is AC? 30. How'd you get 30? 15 plus 15 equals 30, yes. BD is 30. It is also a 30. The diagonals are the same length in a rectangle. They're both 30. BE is 15. AB. Ooh, what's AB? Yeah. opposite sides are congruent. So we have a 27 below, we got a 27 above. And BC, is it? So we need to figure out this side right here. Is it not a right triangle, or is it a right triangle?
Oh, I was thinking of like, triangle.
The little guy?
No, like AB. I don't know.
Triangle ABD is a right triangle.
ABE.
ABE is not a right triangle. Okay. Okay, but we have this side DC right here. We want to find BC, and we have a diagonal with a right angle here. So what do we need to do to figure out this side length?
Maybe 13.
Well, true. How'd you get that?
So I just did like
Pythagorean theorem. Leg squared. So 27 squared plus BC squared equals my hypotenuse squared. And what's the hypotenuse here? 30. All right. Leg squared plus leg squared equals hypotenuse squared. All right. Let's see. What is 27 squared? 729 plus BC squared equals 900. And then what do we need to do? Subtract 729. 900 minus 729. We get BC squared equals 171, and then we need to square root both sides. Good. All right, so we get BC is equal to 13.1. Super. All right, questions on that one? So it's always something to pay attention to when we have right angles. Do we need the Pythagorean theorem? Most likely. Okay. Sorry. Was I hitting your foot?
No.
Okay. Okay, let's look at number 4. Number 4, these, you'll notice, were all side lengths. We were trying to find measures of sides. Here, we're looking for all angle measures, okay? Lots of angle measures. We want to figure out angle, the measure of angle XWY. XWY is this little angle right there marked in blue. All right, this is tricky.
Wait, wouldn't you just do like 180 minus 64 divided by 2, and that's the angle of
Yes, you're absolutely right. So how did you figure that out?
Because the triangle equals 180, and since W and X are both congruent angles.
Okay. So remember, in our rectangle, these little baby diagonals are all congruent. And so what we have here is this upper triangle is isosceles. We have 2 congruent sides, which means we also have 2 congruent opposite angles. Okay? In this triangle, I know that we have 180 degrees, and we're going to subtract our 64, and that gives us 116 degrees to split between these 2 little angles. So then 116 divided by 2 is 58 degrees. So each of these is 58 degrees. All right. Let's see. YXZ. YXZ is this angle in orange right here. How do we figure out that angle? Is it supplementary or complementary? Yeah. So again, we have right angles. So this little corner is 90 degrees. So we just get to do 90 minus 58. And that gives me 32. 90 minus 58. So that orange angle is 32 degrees there. All right. Next, we want to find the measure of angle WVZ. WVZ is right here, this large angle in pink. 180 minus 64, sure. These are a linear pair. They form a nice straight line. If I know 64, I just need the other half. So 180 minus 64 is 116? 116, good. I'm going to write that in, 116, because I like writing all those things in. All right, and we have angle XWZ, XWZ. Oh, hey, XWZ is the whole angle here. What is that whole angle? 90. It's a corner on a rectangle, 90 degrees. All right, and then we also have last here, XZY. XZY is this angle right here. Ha, 58. How'd you get 58? Alternate interior angles. Again, we have parallel lines. So anytime you see that Z shape, you have alternate interior angles, and they are congruent. So 58 degrees, alternate interior angles are congruent. So 58 above, 58 below. Very good thing to pay attention to. All right, questions on those? Don't you just love how colorful it is? Okay, go ahead and turn the page. We're going to look at number 7. Okay, let's see. RT is a whole diagonal, and US is also a whole diagonal. And what do we know about the, thank you. What do we know about the diagonals in a rectangle? They are equal to each other. They are congruent. The diagonals only in rectangles are congruent. So we can say 5x minus 14 equals 2x plus 10. And then what should we do? Clean it up. So we're going to move the 2x over. That's going to give me 3 x's. I'm going to add 14 to the right. So that's going to give me 14 plus 10 is 24, which means x equals 8. How do we find VT? VT is just that little guy. Split it in half. Plug it in first and then split it in half. So we can find the whole diagonal. So like US would be 2 times 8 plus 10. That's 16 plus 10 is 26. So the whole diagonal is 26, which means what's each piece? What is each piece? 13. 26 divided by 2 is 13. So each little piece of these diagonals is 13. And remember, all 4 of those little babies are the same. Okay? All right, so VT is 13 there. Questions on that one? Okay. Let's look at number 9. Number 9. Okay, number 9. VW is this little baby diagonal, and SU is a whole diagonal. All right. How do we relate those two things? Yeah, so you want to take 2 of these? Yeah, sure, because VW is 9x minus 11, which means this other side would also be 9x minus 11. We can just write that with a product of 2. 2 times 2 of those little babies equals the whole diagonal, 16x minus 12. So 2 of the little baby diagonals will give us a whole diagonal. Let's see, so that's 18x minus 22 equals 16x minus 12. I'm going to go ahead and subtract the 16x. So that gives me a 2x, and I'm going to add 22. And we get x equals 5. Good. All right, we need to find WT. What is WT? Yeah, it's the same as 9x minus 11. They are congruent, so we just get to plug it in. 9 times 5 minus 11 is 45 minus 11 is 34. Questions on that one? Okay. So again, all of these we're finding side lengths, and then everything down here is finding angle, 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 angle. I'm seeing a lot of like little confusion. Angles have degrees. We get 180s and 90s a lot, but be careful when we're talking about side lengths. There's none of that. Let's look at number 12. Number 12, we want to find the measure of angle XZW, which is this angle right here. That's what we're trying to figure out. What do you think? Almost. 90
equals x plus 20 plus 5x minus 8.
X plus 20 plus 5x minus 8 equals 90. We know all of our corners in our rectangle are 90 degrees. And so we know we can add angles together to equal that 90 degrees. Why did you say x plus 20 plus 5x minus 8? How do you know this is 5x minus 8? Alternate interior angles. Right here, parallel line, transversal, parallel line. So this little angle, 5x minus 8, is the same as over here. So it is also 5x minus 8. We got that alternate interior angles there. All right, so we have 5x minus 8 plus x plus 20. And those add up to equal how many degrees? What does this little box in the corners mean? 90 degrees. They are right angles. They equal 90 degrees. All right, combining like terms here, I've got 6x's, a negative 8, and a positive 20 is a positive 12. I can subtract 12. That'd be 80, 78, and then divide by 6. I get 13. All right, we need the measure of angle XZW, which is right there, and we just get to plug in for x. So 5 times 13 minus 8 is 57 degrees. All right, questions on that one? Good so far? All right, last one, we're just going to set it up. It's kind of tricky. We just need to solve for x here, and we're just going to get it set up. There's plenty to think about here. All right, what do you got? Any ideas?
We can do 134 minus 180, and that gives us the angle for DHD.
Okay, so we can figure out this angle by doing 180 minus 134, and that is 46. All right, so we get this little angle is 46 degrees. That's nice. That I see a little triangle maybe that we can work with right here. Kaylee.
You do 180 minus 134 and split that by half to get HDF and
Ooh, that is an interesting way to do it. I didn't think about that. You're absolutely right. Yes. I'm not going to do it that way for this stuff, but yes, that will work. Any other thoughts? Remember, my diagonals are all these little baby diagonals are congruent. And because you have two congruent sides, you have two congruent angles. And so if this angle is 5x plus 7, what's this one up here? Also 5x plus 7. All right. And so do we have a triangle? plus 7. All right, so we have two of these little angles that are 5x plus 7 plus the 46, and all of that should add together to be 180 degrees since they're in a triangle. But again, there's multiple ways to solve this. So what Kaylee said is absolutely right. She was able to figure out how many degrees each of these would be because she knows they're congruent. Okay, so there's so many ways to do it. This is one way. There's like 37. Okay. Do you have questions for me? All right, so we have a little worksheet, and you get to skip number 3 and number 5.